So I'll continue with the revision class for the first term exam, for the second term examination. It will be the second day of the revision class. Now, in my previous class, I had given you some formula for the equivalent masses, calculation of equivalent masses or equivalent weights. Okay. Today, I would like to give you some formula for numericals where there are volumetric calculations. So please try to pay attention. Okay. Volumetric calculations. Can you see what you have written on the screen?
Yes, sir.
Volumetric calculations. Okay. Now, volumetric analysis is an important part of chemistry, which involves the measurement of volumes through titration. So after titration, we get a titer value, and using the titer value, the volume of a solution of one substance is made to react completely with the solution of another substance. Now, the point at which the titration is complete is known as end point also. The substance which is used to indicate the end point is, of course, it is called an indicator. So, there are some terms used in volumetric calculations. So, that is what I would like to discuss today. Terms used. The terms used in volumetric calculations are the first one. The first one, it is called mass percentage. It is called mass percentage. Mass percentage. Abbreviated as small w by small w. And the formula for mass percentage is equal to mass of solute divided by mass of solution into 100. So this is how we calculate the mass percentage. This is one formula. Okay. There is one more formula which can be used provided the volume and density of the solution is given. Okay, so in that situation, the formula for mass percentage becomes, this is the mass percentage of, I'm talking about the solute. So again, I will write down mass of solute divided by volume of solution into density of solution. Density of solution into 100. So this is how we calculate by using this formula mass percentage. This is the first term which is used in volumetric analysis, mass percentage. Now, the next one, number two, it is called percentage mass by volume. Percentage mass by volume or volume percentage. Percentage mass by volume, abbreviated as W by V. This is the percentage mass by volume. So the formula for percentage mass by volume is given here. Mass of solute divided by volume of solution into 100. This is the second volumetric term. Second term used in volumetric analysis. So concentration is W by V. The next one, number 3. The third one is called volume percentage, or simply percent by volume. Percent by volume. Percent by volume, abbreviated as V by V. So the formula for percent by volume, percentage of solute by volume, it is given by volume of solute divided by volume of solution into 100. So this is the third concentration term used in volumetric analysis. Okay. Next one, that is number 4. Number 4 is called strength. Strength or concentration. Strength or concentration, grams, in grams per unit, grams per liter. So here the strength or concentration, the formula is mass of solute. This mass of solute, it is in grams. It is in grams divided by volume of solution. This volume of solution is in liters. Okay, so this is the fourth concentration term used in volumetric analysis. The next one, number 5, it is called normality. This one is important. So normality, 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 capital N. The symbol is capital N. So this normality, the formula is number of gram equivalence of solute divided by volume of solution in liters. The number of gram equivalents of solute divided by volume of solution in liters, that will give us the normality. Okay. Now let me work with this formula only to make it more detailed. Now normality, this capital N, you can also write the other formula, which is like this: weight of solute in grams. This I will abbreviate as W2. W2 divided by equivalent mass of solute, that is capital E, multiplied by volume of solution, again in liters. Volume of solution, that is V, in liters. So this is another formula. Now if I write in terms of abbreviation, This N, capital N, which is the normality, you can write it as W2 divided by equivalent mass is capital E multiplied by volume of the solution in liters. Okay, this can be further written properly. W2 into 1000. I am converting it to milliliter now. That becomes W2 into 1000 divided by equivalent mass into V, volume in milliliters. So you can apply this formula. Okay, or if I multiply this normality into volume in milliliter, I will get one more form of this formula, which is W2 by capital E into 1000. Okay, so to define normality, normality is defined as the number of gram equivalents of solute to the volume of the solution in liters. That is the definition. The first formula becomes the definition. Now try to remember this relations, equations, to apply them wherever necessary. Now there is one important equation under normality, which is called normality equation, which is called normality. It is called normality equation. Now, this normality equation is an expression which will relate the normalities and volumes of two reacting solutions. So, you have to apply the normality equation. This question I have given. I'm just giving you a hint only. I will not tell you the question, which question I have given, but in that particular question, you have to apply this equation, which is called the normality equation, where this expression is going to relate the normalities and volumes of two solutions which are reacting in a titration reaction. Okay, so the normality equation goes like this: N1 V1 is equal to N2 V2. If there are two solutions, solution 1 and solution 2, which are reacting in a titration reaction, so that an point comes after some time, then if you know the normality of the first solution, if you know the volume of the second solution, and if you know the volume of the second solution, then you can easily calculate the normality of the second reacting solution. So remember this important formula. Okay. After this, the next concentration term, which is important for you all, is number 6. That is called molarity. That is called molarity. Molarity, molarity, abbreviated as capital M. Capital M. Now the formulas over here: molarity capital M is equal to number of moles of solute, divided by volume of solution in liters. So this is the first definition over here. So molarity is defined as number of moles of solute to the volume of the solution in liters. So by using this, you can define molarity. Again, I can simplify this formula. Molarity is also equal to weight of solute in grams. That is abbreviated as W2, divided by molecular mass of solute. That is, you can abbreviate it as M2 over here. Molecular mass of solute is capital M2 multiplied by volume of solution in liters. Okay, so this is the second step for the same formula for molarity. Now, if I abbreviate the various terms over here, molarity will become equal to W2 on the top numerator, and denominator will have M2, the molecular mass of the solute, multiplied by volume in liters, LITERS, liters. This I can further convert into milliliter. So convert liter into milliliter, we have put divide by 1000. So we get the formula as W2 into 1000 divided by M2, that is the molecular mass of the solute, into volume of the solution in milliliter. Okay, so this is one form of the formula. Or I can have one more form. Molarity multiplied by the volume of the solution in milliliter is equal to, this is easier way to remember, W2 by M2 into 1000. Okay, so this looks like an easier way to remember the final formula for molarity. Okay, so try to learn this. Okay, this formula properly. Normality I've already seen. Okay. After this, again, like normality equation, there is also an equation for molarity, which is called molarity equation. It is called molarity equation. It is called molarity equation, and this molarity equation is an equation for a balanced chemical equation involving, say, N1 moles of reactant 1. If the reactants are given reacting and they are in reacting in moles, N1 moles of reactant 1, that is reactant 1 and reactant 2. That time we apply this formula whenever the number of moles is given. So in such situations, we apply this formula where M1 into V1 divided by N1 is equal to M2 into V2 divided by N2. Okay, so here you have to remember this M1 is molarity of the first solution, V1 is the volume of the first solution, and this M2 and V2 is the for the second solution too. Okay, now for very dilute solutions, if you talk about very dilute solutions,
Sir,
yes,
there is small n is for number of moles.
and yes, N1 and N2 is number of moles. Number of moles. How do you get the number of moles? Do you remember? Huh? Yes. How do you get the number of moles? Number of moles is weight. It is obtained by dividing
Weight
weight
by
mo-
molecular
weight
mass.
by molecular mass. The number of moles is obtained by dividing weight of the given substance divided by its molecular mass will give us the number of moles. Okay. Now, for very dilute solution, for very dilute solutions, this N1, no, if it is a solution, a very dilute solution, if N2 becomes the solvent, that means in that case N2 is very very large. No, so we can equate them. N1 can be equal to N2. We can say that also is negligible over there. So in that situation, the above equation takes this form. It becomes like this: M1 V1 is equal to M2 V2. So remember this also for very dilute solution upon dilution. Okay. So this was the sixth concentration term, which is used in volumetric calculations. After that, the next term which is used in volumetric calculation number 7, that is called molality. 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 Molality, which is defined as number of moles of solute present in 1 kg of the solvent. Molarity is defined as number of moles of the solute. Number of moles of what? Number of moles of solute. Number of moles of solute in 1 kg, 1 kilogram of what? Solvent. That is called molality. Now you can make this clear from the formula. Small m. Molality is abbreviated as small m. Please keep these things very very clear in your head. Okay. Molality is small m. And this small m, that is molality, the formula is number of moles of solute divided by mass of of solvent in kilogram. Okay. So this formula can be further worked upon and we can get one more form. Number of moles, again, if you divide mass of the solute divided by molecular mass, that is number of moles. So I'll expand this formula. So mass of solute in grams, I will write it as W2 divided by, W2 is mass of solute in grams, divided by molar mass of solute. The molar mass of solute, MOLAR, molar mass of solute, that I will write it as capital M2, okay, multiplied by mass of solvent in kg, mass of solvent in kg. So this is the formula. Now by putting the symbols for the various terms over here, I will write down the formula W2 divided by M2, okay, into mass of the solvent. And what do you call this one? I can write it as, instead of working on this formula mass of the solvent, I can write it as W1 also possible. Okay. Now this is in kilogram. This is in kilograms. So I will convert this into grams. So, and then I can get the formula W2 into 1000 divided by M2. M2 is the molecular mass of the solute multiplied by W1, which is the mass of the solvent in grams, because 1000 I have divided. Okay. So this is the formula. This is the formula to obtain the molality of the solute. Okay. Now note down over here. It is independent of volume. This molality is what? It is independent, independent, independent of volume, as well as independent of temperature. If volume is not there, so temperature will also be independent. Over here, this molarity will also be independent, not depend on temperature. Wherever there is volume, that concentration term will be dependent on the temperature. Okay, so this was the seventh concentration term used in volumetric analysis. After that, moving further to the next term, that is number 8. Number 8, we have a term which is called mole fraction, which is called mole fraction, chi, like this, chi, okay, big X. Now, this mole fraction is for, two components. If there are two components, say there are two components mixed together. Components are, say, component 1 and component 2. So whenever there are two components 1 and 2, then mole fraction of each component can be worked out. Say component 1, say it is the solvent, okay, and component 2 is the solute to make a solution. So that time the mole fraction of solute first, mole fraction of solute, that is chi2, is equal to number of moles of solute, that is written as N2, divided by total number of moles. Total number, that means this total number of moles, I'll write like this, total number of moles, like this, and then make it simpler. It becomes N2 divided by N1 plus N2. That gives us the total number of moles. Okay, so in the numerator you will see that is the number of moles of solute. So this formula is for calculating the mole fraction of the solute in the solution. Now, if you are told to work out the mole fraction of solvent, then the similar formula for mole fraction of solvent, chi1, solvent is 1, no? So chi1 is equal to, again I'll write now here directly, N1 divided by N1 plus N2. So this will help us to calculate the mole fractions of each component. Now, please keep in mind, note, important point to note over here, the sum of the mole fractions of the two components is always equal to 1. It is always equal to 1. If I add the, say, mole fraction of component 1, that is the solvent, plus mole fraction of component 2, that is the solute, then it is always equal to 1. This is in fraction. Now remember, mole fraction has no unit. Has no unit. It has no unit. Like others, if you have seen the others, molarity, grams per mole, molality, okay, moles per kg, okay, normality, gram equivalents per liter, that way, So other concentration terms, they have units like grams per liter is there, okay, percentage mass, there will be a unit, percentage of volume, there will be unit, but this mole fraction doesn't have any unit. Okay, now I will just like to give you one problem just now in this class only. I want you all to, I'm giving you a question, I'll write the question on the screen. So try solving it just now, okay? So the question is going like this. Can I write the question on the screen? Can you see the screen?
Yes.
Question. Okay, so I'm writing the question on the screen. Okay, so it is. I'll just select one question based on, say, what do you call, any one of these concentration terms. For example, if I take normality, that is also possible. Okay, so let's take a problem based on molarity. Okay, so the question is like this. It says calculate the mass of sodium acetate. Sodium, calculate the mass of sodium acetate. Let me give you the formula of sodium acetate. It is CS3COONA. Mass of sodium acetate required to make 500 ml of 0.36 m solution. Okay, this is the question. Okay, and uh, molecular mass of sodium acetate, I think you can work out if I give you the atomic masses. Carbon is 12, okay, hydrogen is 1, okay, oxygen is 16, and sodium is, I can write 23. Okay, so this is a direct formula based numerical, and like this numericals will be asked. Okay, so try it. I'm waiting. Okay, don't take more than 4 minutes to solve this sum. I hope you remember the formula, no? Molarity formula. Molarity formula is what? W2 into 1000 divided by M2, or is it M1, molecular mass, into volume of the solution in milliliter. This is the formula. Okay. So apply this formula, put the values directly, and get the answer directly. This one I had given M2. Molarity of the solute is M2. So M is equal to W2 into 1000 divided by M2 into V, capital V, in milliliter. Try to recall the formula, okay? It is very, very important. What is the value of W2? 0.36 m, actually. 0.36 m. Okay, that is the molarity. You have to find the mass. You have to find this. behind this. Others are known. So if you apply this formula, this capital M is what? 0.36. W2 we don't know. 1000 is already
So
there.
answer is 12.96.
Answer is 12 point. No, no.
96.
96. Okay, let me check the answer. Okay, let me work out and check the answer. W2 into 1000 divided M2. Molecular mass of sodium acetate, how much did you get? Molecular mass of sodium acetate?
72.
Is it 72? No, check once. Uh, 12 plus 3 plus 12
82 I
plus
prefer.
32 plus 23. Let's calculate. 5, 7, 8, 9, 11, 12, 1 and 2. 2, 3, 6, 7, 8. It is coming now. It is coming 82, man.
82.
Oh, there is a small mistake. Never mind. Never mind. So M2 becomes 82. And the volume of the solution it's given in liters. So we put over there 500 only, no? Okay. Now make W2 the subject of the formula. So if you make W2 the subject of the formula, it becomes 0.36 into 82 into 500. Okay. And this will get divided by 1000, I think. 501, 502. Okay. Then this, if I multiply 202, if I divide 202, 2021, 28. So it is coming. W2 is 0.18 multiplied by 82. So two decimal places. So multiply it. So if I multiply 18 and 82 in the rough, it to the 16, 36, it to the 64, 41, 44. So it is coming 6, 7, 14, 76 two decimal places. So 1, 2. So 14.76 grams is the answer. Are you getting it? So the mass of sodium acetate is 14.76 according to what information has been provided in the question W. Okay. So that is the answer. Am I clear? Okay. Did you get that?
Yes, sir.
Okay. So you'll get like this problem only. Okay. So let me give you one more sum based on concentration terms. The next sum, let me introduce one more slide over here. Okay. Okay, just a second. I'll insert one more slide. Okay. Here we are. Question. Okay. I will give us some based on say. Okay, nice one. Chlorophyll. Have you heard of chlorophyll? Chlorophyll.
Yes,
You know
sir.
what is chlorophyll? No? The green pigments in plants. Chlorophyll, the green coloring matter. Coloring matter of plants contains 2.71% of magnesium by mass. Magnesium by mass. Okay, so by mass percentage is given. Okay, by mass. Now we are saying us calculate the number of magnesium atoms. Magnesium atoms uh, present in uh, let us take 3.50 grams of chlorophyll. Okay, that is the question. And atomic mass, atomic mass of magnesium, it is given to be, use this value 24.3, okay, grams per mole. This value you use. Don't use 24 only. Use 24.3. Okay, so this is the question. Okay, so this is a slightly percentage by mass is given, but since the percentage by mass is given, they are telling us to calculate the number of atoms present in so many grams of chlorophyll. Okay, so try to work this out. And the percentage is there, 2.71% of magnesium by mass. Okay, try this one. I'm waiting. I can give you a hint over here. How do you get the number of atoms? How do you get the number of atoms of any substance? Number of atoms of any substance. That is what they are asking us. Number of atoms of any substance is obtained by dividing mass by molecular mass. Mass by molecular mass into the Avogadro number. I think you remember the Avogadro number 6.023 into 10 to the power of 23. So if you apply this formula, you should get the answer. But over here, mass is required. So the next thing you have to do is get the mass of magnesium in chlorophyll. Mass of magnesium in how much chlorophyll? 3.50 gram of chlorophyll. So mass of magnesium in chlorophyll. The percentage is given, so we do this way: 2.71%. This divided by 100 into 3.50. So if I simplify this, use your maybe a cell phone or a calculator. 2.71 divided by 100, because it is 2.71%. It is magnesium, no? So 2.7 by 100 into 3.50. Simplify this and tell me what is the mass of magnesium. Simplify this. Use a calculator, okay? You are allowed to use calculators. It is coming how much? 9.4 into okay, let me work out. Okay, 2.71 divided by 100 in 100 is equal to into 3.50. So it is coming 0.0945 gram. So this is the mass of magnesium. Okay. Now after getting the mass of magnesium, now put this value in the formula over here. Put the value in the formula. So mass we have obtained. So number of atoms of magnesium is equal to, we'll put this value which you obtained just now, 0.09485 divided by the mass, the molecular mass or the atomic mass. So put over here 24.3. Okay, and multiply this entire thing by the atomic Avogadro step 6.023 into 10 to the power of 23. Okay, that whatever you get, that will be the answer. So do you have your scientific calculators with you all? If you don't have, try to buy one, because it is allowed in the examination for ISC. Okay. What ISC? Okay, simplify this. If you simplify this, then you will get the answer. You'll get 2.31 into 10 to the power of 21 atoms of magnesium. Okay. So this is one problem, similar problem. Okay. Now, okay. So it's already time up, I think. So I'll just end my class here only. Okay. But before that, just hang on over there. I need to just record your attendance. Okay. I'll just record your attendance and then you may join the next class. Okay. Just hold on. attendance is being downloaded. Okay. It is downloaded. Thank you so much. Have a nice day.
Thank you, sir.